Day, ladies and gents. All right, so we're going to be continuing Unit 7 right triangles. So today we're going to be talking about classifying triangles. That's what we're going to be doing. So here we go. Now, classifying triangles is not on this Hot Topics page, so we will be adding stuff to this. So probably down here at the bottom might be the best place to put it, just really out of the way. All right, so a couple of things we're going to recap. So at the very top here is talking about classifying triangles by the angles, which is not going to be on this particular test, but it'll be just a nice reminder. So let's just have a quick little review about a couple of things. So first of all, by classifying by the angles, we would have there's an acute triangle, there is a right triangle, there's obtuse triangle, and then there's also equilateral. So we're just doing, equiangular, which is just a nice little review. So what we talk about is where if the side lengths were ABC, where C is the longest side. Okay, so we would have for acute. So you remember a squared plus b squared equals c squared. Well, when C is less than a squared plus b squared, then it's acute. Okay. When c squared is equal to a squared plus b squared, it's a right triangle. Okay. If c squared is greater than a squared plus b squared, so when c squared is greater, then it's obtuse. And if a equals b equals c, so if all three sides are equal, then it's equiangular. So this should just be a nice review. So just this part right here. Okay, we've talked about this too, just classifying by things. And I'm just going to show you this part. And you've seen this before. You don't really have to copy this down if you don't want to. We're just doing just a little review. So if you take the two sides, you subtract the two numbers, you add the two numbers, and that third number is in the middle, then that means it's a triangle. And then you can compare the angles, right? So how does c squared compare to a squared plus b squared? So if it is, so when we do that, we get 81 and 58. Well, that's greater, so that'd be obtuse. Okay, and then over here, right here, we're just doing a review, no worries. So we would have A, B, and C, where C is the longest side. You would compare them, first of all, just to even make sure it's a triangle in the first place. And then we would have c squared, which is the biggest side, and a squared plus b squared. How do they compare to each other? So we got 841 and 841. Oh, they're equal, so that's a right triangle. And then down here for number 3 and 4, so for number 3, ABC, because C is the longest side. First of all, we need to make sure it's even a triangle before we start. So we subtract the two numbers, add the two numbers, and we get these numbers right here, 7, 15, and is the third side in the middle? No, it's not. So I'm not even going to take the time to find out what type of triangle it is, because if it's not even a triangle, then it can't be a particular type. Okay, and this last one right here, you have A, B, and C, where C is the longest side. You take the first two numbers, you subtract them, you add them, you make sure that the third number is in the middle. Okay, so now that we have that, so it's a triangle, so we can go on to the next step. So how does c squared compare to a squared plus b squared? You plug them in, you get 484 and 557. You eat the bigger number and you point and laugh at the smaller number, so it's less than, which would be acute. All right, so that was just a review. Now, if you didn't copy that down, that's totally okay. So you could just cross that part out. I'm totally all right with that. But I just wanted, if you needed to complete that page, I'm totally cool with that. So you can either have copied that down or you could have crossed it out, whichever part you prefer. So your choice, but you were at least able to see that. Okay, so, but what we were trying to get to is down here, the sides. All right. So down here at the sides, right here, it says, very important, equilateral triangles has 3 equal sides. Isosceles triangle has 2 equal sides, and scalene has no equal sides. All right, so that part is important. So that's something that you probably want to put on this page right here. So let's go ahead and do that. So I'm going to grab a pen, something separate here. Okay, so we know classify by sides. So classifying. So we're going to be classifying. So if we could just go by sides. We classify by the sides we have. So we're just looking at our notes right here. So if it is equilateral, then 3 equal sides. If we have isosceles, we have 2 equal sides. And if we have scalene, we have 0 equal sides. So no sides are equal. Okay, and then there is, we're going to be classifying by something else as well, which is, so still classifying. All right, so still classifying. So this is by special right. I'll just zoom in just a little more. Okay, so we're going to be getting to this. So if it's a 45, 45, 90, now the list from least to greatest would be x, x, and x radical 2. We'll be getting to that in just a minute. And then there is for a 30, 60, 90, there is x, x radical 2, and then there's 2x, right? But we are going to be, x radical 3. Sorry about that. And then there is, and another way to write that would be x radical 4. So this one is the one that you want to use more. So now that will make sense in just a couple of minutes. This right here will make sense in just a couple of minutes. So that's us classifying. It's very important. So we'll just keep this next to us the whole time. All right, so here we go. So number 5. Okay, so the first thing we need to do is actually graph this. So, so we're going to be classifying this. So -2, -3, 1, 2, 3. That's my A. And then 6, +1. That's my B. And 3, +7. That's my C. Okay, so we're going to be using our straight edge. Connect the dots. Okay, and then we need to find all 3 sides. We need to find all 3 sides, and the best way to do that is Pythagorean theorem, right? All right, so this side right here, where this was C, all right, this right here is starting at the point and going towards the corner. That is 1, 2, 3. So it's 3 squared, and starting at the point and going towards the corner. 1, 2, 3, 4, 5, 6. Okay, and what we get is that's 9, so that equals x squared, right? All right, so 9 plus 36 is equal to x squared. So using your calculator, right? So 9 plus 36, we get 45, is equal to x squared. So we got, and then you square root both sides, right? So we got the square root of 45. So this is me showing more work than I need to. All right, so we got the square root of 45, right? Okay, now let's do another side. So if you notice, I always start at the point and go towards the corner. So 1, 2, 3, 4, 5, 6, 7, 8. And the reason is because if I start at the point at the corner and I go towards the point, I might actually stop at where I think the line is and not go to the point. And it happens all the time. So always start at the point and go towards the corner. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. And then 1, 2, 3, 4. And so 8 squared plus 4 squared, and you get 80. So square root of 80. Okay, and then right here, make a right triangle. All right, and we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 squared, and we have 1, 2, 3, 4, 5, plus 5 squared. So 10 squared plus 5 squared, and we pop out with 125. So that's the square root of 125. Okay, so now we're talking about equilateral isosceles or scaling. All right, so with that, look at the sides. We have 45, 80, and 125. And are any of them equal? No. So this is definitely scaling. None were equal, so this is definitely scaling. Now here's the thing. If they are scaling, right? If they're scaling, then they might, so notice that a special right has two equal sides. So 2 equal angles means 2 equal sides. So if it's isosceles, it might be 45, 45, 90, and you would check this. If it's scaling, you're going to check if it's a 30, 60, 90 by using these. All right, so this was scaling. So all the sides were different, right? So what we're going to do is see, are these 30, 60, 90? So what you're going to do is you're going to put them in order from least to greatest. From least to greatest. So in this case, I actually have them in order. So that would be, I'll put this in pen here. So from least to greatest, we have square root of 45, the square root of 80, and the square root of 125. Okay, so we're going a step further right now. We're doing this. Okay, so I'll zoom in. All right. Okay, so now I want to know, does it follow this pattern of x radical 3, and x radical 4, which is the same thing as saying 2x. So that's what we're trying to do. So I want to know x radical 3, and x radical 4. So if this part was true, so this would be 45, right? Okay, so if this would be square root of 45 times square root of 3. And this right here would be, so just taking the 45, square root of 45 times square root of 4. And we're trying to see, are these equal? I ran out of room, so I'll put it up here. So this would still be the square root of 45. And then this right here, 45 times 3, would be the square root of 135. And 45 times the square root of 4. 45 times 4 will be the square root of 180. So the question is, are these two the exact same thing? No. No. So this is not a 30, 60, 90. So it's only scaling. It is only scaling. So what? So I wanted to take the next step and see, is there a chance that this right here was a 30, 60, 90? It's a scaling, but was it a 30, 60, 90? No. So that didn't work. All right. And you might be able just to look at that by taking, and it happens sometimes, so you could have just taken the corner of your paper and measured it. So that's another thing you could have done. So if I take the corner of my paper, just taking a scrap of paper right here. So if I measure the hypotenuse, so it's right here. Remember how that's 2x, right? So if you take the shorter side, is that half of that distance? Is that half of it? It looks just a little more than halfway across. So I was like, I don't feel like this is right. Okay. So I'm just putting more work than needs to. All right, so number 6. All right, let's do the same thing. Okay, so we're going to plot the points. So we're going to go -2, +5. Okay, that's A. +3, -3. It's your B. And -2, -7. That is your C. Okay, so now let's take our straight edge, connect the dots. Okay, all right, so then, all right, let's find all of our distances. Okay, so this distance right here Okay, that is 1, 2, 3, 4, 5. So that's 5 squared plus, start the point, 1, 2, 3, 4, 5, 6, 7, 8. 8 squared. All right, so 5 squared plus 8 squared. And we get 89. So that's a square root of 89. All right, this one right here. 1, 2, 3, 4, 5. So that's 5 squared plus 1, 2, 3, 4. 4 squared. So 5 squared plus 4 squared, and we get 41. So square root of 41. So equals square root of 41. And then this last one, okay, so this one's the one that a lot of people get confused on. All right, so 1, 2, so this is, we can actually just count the distance, right? So so we didn't make a right triangle out of this, so it's, so there's 0 squared plus, and then you just count the height. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squared. And that's equal to the square root of 144. So I want you to leave it like this for many reasons, because that's really going to help you out because of stuff. Okay, so right off the bat, notice that all 3 sides are different. So this is definitely scaling. So it's definitely scaling. Now the question is it 30, 60, 90? Okay, so so if we fold it out, it kind of looks like it. So we're just going to double check. Or you can take the corner of your paper and make sure that's a right angle. So see that? It's not a right angle. It's not a right angle. So I know it's not going to be scaling. So I could go ahead and stop right now. Or sorry, let me try again. I know for a fact that it's not going to be a right triangle. So by taking the corner of my paper, this is not right triangle. So if it's not a right triangle, then it can't be a 30, 60, 90. So not 30, 60, 90, there's no way. Okay, but you guys need another example of seeing that, so let's just do it. Okay, so but we're just going to keep going. So put them in order from least to greatest. So we have square root of 41, we have the square root of 89, and the square root of 144. Okay, so we're going to see if this is a 30, 60, 90, which is not, but we're going to do it anyway. So it's x radical 3, and x radical 4. Okay, so we're going to start with this. If we know for a fact that our x is square root of 41, so starting with that, we're going to take the 41 times by 3, and that would be the square root of 123, which right off the bat, it's not going to work because it's not the same as our black. All right, and then 41 times 4, that is the square root of 164. These are not the same, so it's definitely not a 30, 60, 90. Okay, so all it was scaling. That was your final answer. It was just scaling. All right, move on to the next page, guys. All right, so I'm going to just do 2 problems for you. I'm going to do number 8 and number 10, and then you will be in charge of the rest. Okay, so first thing we want to do, so on all of these problems, we're going to add an extra thing. Okay, on all of these, we're going to add isosceles. Isosceles triangle. We're going to add on all of them. Okay, that's the first thing we're going to do. Add the box that says isosceles. Isosceles. All right, sweet. All right, so we are skipping number 7. You are in charge of number 7. All right, so we're going to go straight to number 8. All right, so first thing we want to do is graph this. We are going to graph it. All right, so actually, I think I'm just going to do number 8 and just be done. Number 8 and done because I already gave you some other examples because I'm fabulous. All right, so number 8, and then we are done. All right, so 3 and positive 7, and that will be A. 1 and 3, that would be B. And 4 and 4, that will be C. Okay, so take your straight edge, connect the dots. Okay, so now we need to find all of our distances. So let's just do one at a time. So this one right here. So this is 1 hop, so it's 1 squared. And this is 1, 2, 3 hops, 3 squared. So 1 squared plus 3 squared, and we pop out with the square root of 10. Okay, and then we have this one. That is 1, 2, 3, and 1. Ooh, we already have something that's equal. Nice. And then this one right here. So 1, 2, 3, 4, and 1, 2. So 4 squared plus 2 squared, and you pop out with the square root of 20. Awesome. Okay, so right off the bat, this is definitely isosceles. Isosceles because there are 2 equal sides. So it's definitely isosceles. The first thing, so it's isosceles, check. Now, if it's isosceles, then there's a chance that it's a 45, 45, 90, because see how there's 2 angles equal? That means that 2 sides would be equal. So we're going to try 45, 45, 90. Okay, so in black, we're going to take the numbers and put them from least to greatest. So that would be square root of 10, square root of 10, and square root of 20. And using 45, 45, 90, does it follow x, x, and x radical 2? That's what we're saying. Does it follow x, x, and x radical 2? All right, so knowing that this is true, so if x was definitely x radical 2, then we're going to finish this off. Okay, so x would be, I said radical 2, I meant radical 10. If x was radical 10, then your x would be radical 10, and this would be radical 10 times radical 2. So that would still be radical 10, and radical 20. And is that what we have? Yes, it is. That is exactly what we have right here. So that's happy. So that means that this is also a 45, 45, 90 triangle. Because it's happy. All right, so this was 2 different things. So if it's a 45, 45, 90, and it's an isosceles triangle. Awesome. Okay, so you guys are in charge of page 11 and page 12. And you guys have a great and wonderful day.